All right, guys, so we're starting note 16.1 today. We've got this chapter and one more. We're going to be talking about arcs, semicircles, and central angles. This is all just pieces of circle. They're actually pretty easy. The first thing we're going to talk about is the arc. It's just a part of the circle. So if I drew this circle right here, let me zoom in here, and I put 2 points of it, and say I call them A and B, I have arc AB. Now, when you write out something like that, it's always going to be the shortest distance between what you write, so it automatically assumes it's going from A to B this way. But if you were to put a point C right here, and you said A, C, B, that would mean now we're going this other direction. So that's kind of how you name them. We have the central angle. So let's draw a circle here as well. If I have this separated out, and let's say that's the center C, and I have an angle right there that comes off of the center, this arc 1 is the same as this central angle. This right here is the central angle. So central angle, it's an angle at the center. It's pretty easy. So we have arc 1 and we have arc 2, and these angles right here, we have this really big angle where I'm doing it in blue. Those are the same as the arc lengths, and we'll talk about that more later. Then we split it up into 2 different kinds of arcs. We have a minor arc. So let's say I have a circle, and I have this arc right here, and we have this central angle that's touching them. If I said, okay, that central angle is 90 degrees, well, there's 360 degrees in a circle. So since it's less than half of that, well, that's the minor arc. And then I'm going to stay on the same picture here. If we were to name that, by the way, we could say minor arc AB. And then we also have this major arc. And that's what we call this other one, the one that goes from A through C back to B. Arc ACB is the major arc, and it is bigger than 180 degrees. So I'm going to kind of write something over here. If you're trying to classify between a minor arc and a major arc, a minor arc is less than 180 degrees, and a major arc is greater than 180 degrees. And we'll see more about that tomorrow. So those are your arcs. And then actually, and it doesn't say this on the notes, but if it's exactly 180 degrees, that means we have a semicircle. So we'll just add that one in. So those are the classifications, kind of like acute, right, and obtuse. So we're just going to name some stuff here at the bottom, guys. It wants us to name a central angle. We're assuming that it's circle E, so E is the center. Well, I've got this central angle right here, so I'm going to say angle, and it is an angle, L-E-Y. So central angle L-E-Y, or Y-E-L. It wants a minor arc. Now, just looking at this, you should be able to kind of tell that this is the short part of the circle. It's definitely smaller than the other side. So I'm going to go ahead and come over here and say arc. And you can say L-Y or arc Y-L. Either way, it's fine. And then the major arc, that's this arc that goes around the circle this way. So we have to name it a little different. It's still an arc, but now I'm going to call it L-U-Y, because that's saying I'm going from L through U, then back to Y. So that would be the major arc. Let's look at the next page. We have a little theorem here, and it's a pretty easy one. It says the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. All that means is if I have like these 2 angles right here in example 2, that plus that is always going to equal 360. Even if it's separated into more angles, the sum of all of them will always be 360. And this goes back to what I said a second ago. Arcs are measured by their corresponding central angles. So it means the central angle is equal to the arc that it cuts off. So let's look at these questions here, and I'll kind of show you what I mean. It says, what's the measure of angle PCM? Well, PCM is right here, and it tells it's 110 degrees. So you see how this central angle kind of cuts off this arc that goes from P to M? Well, whatever this angle is, that arc length is also that number of degrees. So I also know that arc PM is 110 degrees. Then I need to find this other piece, and it tells me PM or PNM, meaning it goes over here through N back to M. Well, I know there's 360 degrees in a circle, and with the minor arc, we used 110 of those. So I just do the subtraction, and you get that PNM arc is 250 degrees. Then it says what kind of arc is arc PM, and how do you know? Well, PM is this short one right here. It's 110 degrees. It's a minor arc. And I know that because the measure of the angle is less than 180 degrees. Okay, so that's pretty easy to find out. Now this goes to the semicircle. We kind of put it on the front page, but it's an arc with a measure of exactly 180 degrees. It's named by its endpoints and 1 point on the semicircle. So if I have my circle and I have like a diameter going through it like this, let's say I have point A here, point B here, and then I have this point X out there. I can say arc BXA. And if it's a semicircle, that means that it's 90, I'm sorry, not 90, half of 360 would be 180 degrees. So a semicircle is exactly 180 degrees. So we can use that to look at the questions below. It tells us a couple of things, and guys, this is going to start getting bigger and bigger as we go on. It says in circle E, so they're saying E is the center. The measure of angle AEN, this angle right here, is 18 degrees. So I'm going to label that. It says JN is a diameter, and that tells us some stuff. So JN is the diameter, and measure of JES is 90 degrees. So I'm going to go ahead and put 90 right there. Now it's going to ask us some questions. So it says find the measure of AN, of arc AN. Well, that's the easiest one because here's AN. It's cut off by central angle EAN that's 18 degrees, so it's also 18 degrees. Now it asks us for JA. So JA is this big space right here. Well, the way we'd find that, guys, is this diameter cuts that circle in half. So I know this JAN arc, the whole thing, is 180 degrees. Well, I've used 18 of that on the little piece of arc AN, so I subtract 18, and I get 162 degrees. So 162 degrees. And then the last thing it asks us for is arc JAS. So guys, this is a lot. That's all the way around, JA all the way to S. Now I know there's 360 degrees in that circle, and I know the only piece of arc we didn't use is this right here that's 90 degrees because of its central angle. So subtract 90 degrees, and I get the arc JAS is 270 degrees. Okay, so use what you know. It makes it pretty easy a lot of the times. So let's go to the back page, or the next page. I guess it's the back page yet. And we have a big set of things here. And my suggestion is, guys, try this out on your own. It says that FD is tangent to circle O. So I'll tell you what that means. If we have this radius from O to D and FD is a tangent, that means we have a triangle here that has a 90-degree angle in it. So you might pause for a second, try to find some of these. When you kind of get stumped, you can come back to the video. So it's kind of, I mean, it doesn't necessarily have to go in order here, guys, but I am going to start with arc AB. So I have this arc right here, AB. It has a central angle of 45 degrees, so arc AB is 45 degrees. All right, so we got it started off, and you can kind of skip around if you need to. Let's see, the next one says arc AD. So this is arc AD, that big red line right there. Whoops, sorry. I don't think we're ready to find that one yet, so I'm going to hold off. Let's go look at AC. AC we can find from A to C. We go to the shortest distance, so it's only 2. Now, I know this is 45, and I know this is 90, so 45 plus 90 will give me the whole thing. Looks like it's 135 degrees. So we got some more here. Let's see, after that, it looks like it's asking for BC. Can we find, oh, BC is easy. We already pretty much have it. It's 90 degrees. Let's see, how about ADC? So that's all the way around. I don't know what A to E is yet, so I can't find that. So we'll put that off for just a second. So let's see, how about ACD? All the way from A to C to D. I think we can find that one. We know AB, we know BC, and we actually know CD as well as 85. So we can add all those up. It looks like we have 45 plus 85 plus 90 makes ADC 225 degrees. I'm sorry, ACD. I wrote it on the wrong one. 220 degrees. Okay. So we've got some more here. I think, guys, and let's look at this triangle here, because this one right here, the EOD angle, we can actually find, because we have a right triangle here. We've got 90 degrees and 38 degrees. So I can do 180 minus 90 minus 38, and I got 52 degrees. So I know that this arc ED is 52 degrees. And because of that, now I can find that arc AE, this one right here. 360 minus 45 minus 90 minus 85 minus 52 should give me that, which is 88 degrees. And then that gives me this central angle right here, 88 degrees. So guys, I know this gets a little bit hairy, but if you're having any problems, of course, we can work on it tomorrow. So let's see if we have, what else we have. They needed A to D. Well, I can do 88 plus 52, and I can get 140. So that's all the way around here. Let's see, we need A, D, C. I feel like we can find that now. So from A all the way to D to C, so 88 plus 52 plus 85, there's the 225. I knew it was in there. Let's see, E to D, we already got it, 52 degrees. A to E, we already have that one, that's 88 degrees. Then it asks for those angles that we actually found. So angle DOF is the 52 degrees. It's right here. And then we have EOA, which we found to be 88 degrees. So guys, I like these, but you have to be careful. Fill it out. It'll help you out a lot. And so then the last one here, I'll kind of start you off because it's pretty easy after that. It gives me a bunch of expressions going around the circle, and it tells me to solve for X and then plug it back in and find those arc lengths. Well, you should know one thing about all these expressions. If I add them up, they equal 360 degrees. So I have 3X plus 1 is 4X, plus 4 is 8X, and it looks like I have 10X. Let's see, 15 plus 15 is 30. So it looks like I have 10X plus 30 equals 360, and then we can solve that. So I subtract the 30 from each side. I get 330. I divide both sides by 10, and I get X. X is 33. So then I can plug this in up here, guys, and I know that you can, oh, it doesn't ask for X, but we know X is 33 now. Now I can just plug it into each of them. I'm just going to kind of go through this quick. AOB, this angle right here, would end up being 33 degrees when I plugged it in because X is 33. Then BOC would be 132 degrees. COD is 81 degrees, and 114 is the last one. So guys, the reason I didn't do that is all we're doing there is plugging X into each one of these expressions, and I don't think we have any trouble there. So I know that was a little bit long, but if you have any questions on your homework, you can ask them tomorrow in class. Good luck.